Hello everyone, in this video we look into the superposition principle. So it is one of the important principle that you need to understand when you want to investigate the event of interference of wave. What is the superposition principle? Let's look into our note here. Principle of superposition state that when two wave, first we must have two wave. We must have two wave. Principle of superposition. So the first one we must need two wave, and the two wave must be in coherent. Coherent. So what is meant by coherent? We had discussed about the term coherent before in our previous video, which is coherent means the two wave must have same phase, same amplitude, and same frequency. So if both waves have the same phase, amplitude, and frequency, then we can say that the waves are in coherent. Must be same. So for superposition, when the two waves where they are incoherent, move simultaneously. So at the same time, at one time, if we look into the wave and both of them are moving at the same time, which is simultaneously. So here we have the word simultaneously, at the same time, and coincide at a point. So what will happen? Let's say let's look into our example here. Here we have two different waves. Wave one coming from this direction, and wave two, coming from this direction. So at one point, they will collide to each other. They will coincide to each other. For wave one, initially, they have amplitudes equals to A. A here is just variable. We also can add another number, 1 cm, 2 cm or other, but we use variables A here. And the other wave, which is here, the blue one, remember it is two coherent sources, so that means they have the same amount of amplitude. If here A, so the amplitude here is A. Or we can also say this is the displacement, the maximum displacement. So A and A. And then this one will move in this direction until at this point. Same with the blue one, will traveling towards this direction until this point. So at this point, let's say this point as C. So at point C, what will happen? One, they are coinciding to each other. Once they are colliding to each other, it will produce one big displacement. Here some of the displacement at that point. So at this point, the displacement produced is equals to, the displacement here we can say it as amplitude here, amplitude. So the displacement, or the change of position of point on the wavefront, here is equals to sum of the displacement of the individual wave by vector method. So how we can look into this? Equals to sum. When we look at the word sum is used here, so sums means that we need to add. So A, the first one, remember the first displacement, and then plus A. So this is the displacement or amplitude for the second wave. So A plus A, we will get equals to A. So the displacement produced will equals to the sum. We add A plus A by using the vector method. Vector method, that means we need to take, or we need to consider the direction. If it is in same direction, So it is positive A plus positive A. What happens if we have two waves but in opposite direction? If they are in opposite direction, then we need to put A minus A or A plus, okay, we just use vector method, A plus, okay, it is plus, still the sum, so sum, still use plus, but since the other amplitude is in opposite direction, so we use negative A. Okay, there's one we will look later. So for the first case, we just look into what will happen if we have the two crests. Okay, here we have two crests. Okay, remember crest is the maximum position of the wave or maximum displacement of the wave on the upper part, measured from the equilibrium position. Okay, let's say here we have wave. This is the equilibrium position, the middle line. So maximum amplitude we have 1, 2, 3, 4. Okay, this is not a pretty wave. Okay, let's draw another one. Okay, where are the maximum displacement? Here we have maximum, 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 and maximum, and then maximum. So we have 5 maximum, but crest only the upper part. So here we have crest, and then crest, and then crest. So at the lower part, we call it as trough. Okay, just a few revision from what you learned in your form 1. So here we have 2A. Okay, once they are coincide or once they are collide to each other, they will produce one amplitude, one larger amplitude, which is equals to 2A. And then what will happen after the event where they collide to each other? Okay, after the event, so the blue one, okay, the blue one will continue its motion with the same initial displacement, which is equals to A, while the other, okay, the red one also will travel based on the initial direction. So in this direction towards our left hand side, and the amplitude is back to normal, which is equals to 2A. So the amplitude becomes larger only at this point C, where at that point the two crests collide to each other. So the same case also can be applied when we have two trough. Okay, so that one we look into the upper part of the wave. So what will happen if we have two trough? Okay, we have two trough. So this is trough. Same case, this one towards right, this one toward left. So at this point, they will merge together or they will coincide to each other. And what will happen at this point? It will produce another larger displacement, which is equals to A plus A. So to 2A. If we have here 3 cm and 3 cm, so what we'll get? 6 cm. Just add the two number. And then after the event, after colliding, they will back to its original motion. Okay, back to its original direction with its original amplitude. Okay, this superposition produce constructive interference. So this is what we call as constructive interference. Okay, let's try to summarize here. Constructive interference. So this is constructive interference because the disturbance at constructive. Okay, constructive. Why constructive? Because the amplitude produced being constructed into a larger one. Okay, normally it become twice. Okay, amplitude become twice. Okay, produce a wave that has twice. Okay, twice the amplitude of the individual wave, but has the same wavelength. Okay, wavelength is not changed. The point that is the constructive interference produced known as, so the point where this constructive interference occur, it has its own name, which we call as antinode. Okay, antinode. Antinode point. So what is antinode point? Antinode point is where the constructive interference happen, and it always produce two times of their larger, two times of their initial amplitude. Okay, so this is the first case. The second one, okay, so the first one when we have two crests, the second one we have two trough, and the last one, okay, the last case that we need to consider is the superposition of crest and trough. Okay, crest and trough. So let's look into this one. So crest and trough, that means we have amplitude but on the different part. Okay, here we have same amplitude. Why same amplitude? Because they are incoherent. Okay, but the direction, this is on the upper part of the wave, this is lower part. Okay, this is the middle point or the equilibrium position. Okay, they will move in this direction and this one in opposite direction, and then they will collide to each other. What will happen, what will produce here, okay, by the vector method, okay, by using the vector method, remember, so the amplitude produced, okay, amplitude produced will be equals to, okay, the first one is equals to A. Let just consider the upper part as positive. So the opposite side, which is the lower part, will become negative. Okay, this is the lower part, and what is the amplitude? It is equals to A. Minus A. So if we add these two number, okay, remember it is sum vector method. Okay, vector method. So A open bracket minus A, it will become 0. Okay, and this 0 amplitude just occur at this point only, at the point where the two waves coincide to each other. But after the event, they will back to its original motion, back to its original direction, and back to its original amplitude. So this one will continue in this direction. Okay, this one, the first one, will continue in this direction, and the second one will continue in this direction. So this superposition produces destructive interference. This is what we call as destructive. Okay, as you can see here, the amplitude being destructed, okay, from A to 0. So destructive interference. Because the disturbance reduce, okay, the disturbance or the amplitude, okay, reduce. The destructive interference produce a wave that 0 amplitude. So amplitude becomes 0. Okay, for constructive, amplitude is twice. But for destructive, amplitude becomes 0. The point that the destructive interference produce known as the node point. Okay, so this is the point where it occur. We call it as node point. So destructive, amplitude equals to 0, node point. For constructive, amplitude become twice, and we call it as antinode point. So that is about superposition principle. Okay, then we will continue in our next video and see you later. Thank you.